Hi, good evening, everyone. This is Shefali Singla, and in this session, we are going to discuss two methods for solving the recurrence relation. That is, Master's Theorem basic case cover करेंगे and extended Master's Theorem. Then we'll talk about recursive tree method. तो कल वाले सेशन में हम लोगों ने substitution method discuss किया था, and in today's session, we'll be covering the remaining two methods. So those who have joined the session, guys, quickly give me the confirmation so that we can quick start with our session on solving the recurrence relation. Okay. So I hope now you guys are comfortable with the term recurrence relation. आप लोगों को पता है कि recurrence relation क्या होता है और क्यों solve कर रहे हैं. So basically we want to return the time complexity. We need to do the comparison between multiple algorithms which are available to solve a particular problem so that we can pick the best one and it goes to the implementation phase. So I guess Master's theorem is the one which is most popularly used to solve the recurrence relation, but there are few drawbacks with the Master's theorem. Directly cut short करके हम main point पे आएंगे. I'll not go into the much technical definition. Simple सी language में understand करेंगे. बाकी जो you can say जो theoretical definitions है वो बहुत जगह पे मिल जाएंगी. You need not to write down all these points. Anyhow, I'll be sharing this PDF in our Telegram group. We'll talk about that later. Okay, but please just focus on understanding the concept. So first of all, usually when we are given with any recurrence relation, this is of the format T of n is equal to a T n by b plus f of n. ये क्या represent कर रहे हैं? This is representing that T is some function, कोई process है, कोई function है जो आपको n elements के ऊपर लगाना है. Okay, so for example, sort is one function. I'm writing sort. Sort is one function and I have to sort n elements. So n will be the number of elements. So n is representing the size of the problem. Now a t n by b, a is representing that the problem is divided into how many sub problems. So a is representing the number of sub problems. For example, कल हम लोगों ने बाइनरी सर्च के लिए एग्जाम रेफरेंस रिलेशन कंसिडर किया था. सो दैट वाज टी ऑफ एन, और यू कैन कंसिडर इट फॉर सॉर्टिंग. आप एक ही बार में लार्ज प्रॉब्लम को सॉल्व नहीं कर सकते. हाय मैम, एक स्मॉल कंप्लेंट है. व्हाट इज दैट? फन लर्निंग क्या हो गया? अभी तो मैंने सेशन शुरू भी नहीं किया. आई हैवंट डिस्कस्ड एनीथिंग. स्टार्टिंग में प्रॉब्लम आ गई. टेल मी व्हाट इज द प्रॉब्लम. Definitely I'll do my best to resolve it. Okay, so a is representing the number of sub problems. For example, we have n elements to sort. हमें n elements को sort करने. So we are dividing this problem into the smaller parts. हम कब तक small parts में divide करेंगे? Until we reach to the termination condition. So n by 2 elements are there on the left hand side, n by 2 elements are there on the right hand side. Again, I'll be dividing this into two parts. So basically, if we are given with a problem and it is large in size, then we are going to divide it into two parts. It can be divided into three parts, four parts, depending on your algorithm. So basically here, we will be saying that since we have to work on both the functions, if we are applying the function t on the original problem, then I have to apply the same function on both the parts. So T of n का solution find करने के लिए what we need to do is we need to find out the solution for the first sub problem, solution for the second sub problem, and then some additional time is required to might be merging the solution of these two problems, or it might be taking to divide the problem into the sub problems. So I'm just representing this with the term f of n. This is some additional time. तो इसको हम लिख सकते हैं t of n is equal to 2tn by 2 plus f of n. तो यहाँ पे 2 क्या represent कर रहा है? It is representing that there are two sub problems. So A is representing the number of sub problems, where n by b is representing the size of each sub problem. If I'm dividing this into three parts, for example, n elements are there, I'm dividing it into three equal parts, n by 3, n by 3, n by 3. So I might be writing the recurrence relation as T of n is equal to कितने parts में divide हुए? 3 parts में. What is the size of each subproblem? It's n by 3. Some additional time is required. मैम टेक्स्ट बुक में 2024 के लिए लाइव सीरीज कब स्टार्ट होगा? 2024 के लिए डाउट कैसे क्लियर करूं? फन लर्निंग, आप डाउट्स अभी मेरे लाइव सेशंस चल रहे हैं ऑन यूट्यूब, और जो सुपर कोचिंग में लाइव सेशन स्टार्ट होंगे, नो मैम आपसे रिलेट नहीं है, मैंने 2 साल का कोर्स लिया था. ओके. Basically what is there, एक्चुअली लाइव सीरीज अभी इसलिए स्टार्ट नहीं हुई है क्योंकि जो न्यू स्टूडेंट्स है, यू हैड टेकन द कोर्स फॉर 2 years, बट जो 1 year वाले स्टूडेंट्स है या जिन्होंने अभी सब्सक्रिप्शन लिए, दे आर लर्निंग द कॉन्सेप्ट्स, राइट. यूजुअली हम जून जुलाई में स्टार्ट करते हैं, मई जून जुलाई, तो अभी जून स्टार्ट हुआ है. मोस्ट प्रोबेबली इन अ मंथ और सो will come up with a live series. तो उसमें आपकी क्विक रिवीजन, क्योंकि जो लाइव सीरीज है ना, आपको मालूम है कि सुपर कोचिंग में द लाइव सीरीज वी आर जस्ट हैविंग द लाइव डाउट सेशंस एंड क्विक रिवीजन सेशंस. जो डिटेल सेशंस हैं कॉन्सेप्ट्स के ऊपर, दोज आर अवेलेबल इन द रिकॉर्डेड फॉर्मेट, एंड एन नंबर ऑफ रिकॉर्डिंग्स आर अवेलेबल टू कवर वन पर्टिकुलर टॉपिक. एक टॉपिक को कवर करने के लिए काफी सारी रिकॉर्डिंग्स अवेलेबल है. सो आई डोंट थिंक, जब तक आपने कॉन्सेप्ट्स क्लियर नहीं किए हैं, जब तक आपने डिटेल में टॉपिक को कवर नहीं किया है, इट विल बी बेनिफिशियल फॉर यू टू अटेंड द क्विक रिवीजन सेशंस. तो क्विक रिवीजन सेशंस में उसमें कोई फर्क नहीं पड़ेगा. Okay, but if you had taken the 2 year course for the last year, तो you must be comfortable with some subjects. बाकी subjects को depth में cover करो and try to attempt the mock test. Okay, प्रैक्टिस क्वेश्चंस करो, मॉक टेस्ट करो, और जो भी आपके डाउट्स आ रहे हैं ना, एक डायरी मेंटेन करनी शुरू करो, टॉपिक बाय टॉपिक. पहले सब्जेक्ट कवर, एक सब्जेक्ट उठाया फॉर एग्जांपल डेटा स्ट्रक्चर्स, तो उसमें आपने जब मॉक टेस्ट अटेम्प्ट किए, तो या तो कॉन्फिडेंस आएगा या डाउट्स आएंगे. डाउट्स आ रहे, जिस भी टॉपिक में आ रहे, जस्ट नोट इट डाउन, और जैसे ही लाइव क्लासेस स्टार्ट होंगे क्विक रिवीजन और डाउट सॉल्विंग वाली, उसमें आप अपने डाउट्स पूछो. सो दिस इज हाउ यू कैन डू दैट. गेट क्लियर करना है, इसलिए 2 year का कोर्स लिया था, लेकिन कॉल नहीं लग पा रहा है, बहुत फ्रस्ट्रेटेड फील कर रहा हूँ. यू नीड नॉट टू फील फ्रस्ट्रेटेड. I'll forward your this query to the tech team and soon you'll get the call from them. Okay, मैं आज ही शेयर कर देती हूँ ये टीम के साथ that you are facing the problem, but I don't think कि आपका यूजर नेम एक्चुअली फन लर्निंग होगा. So I am just knowing कि आप क्योंकि YouTube is the open platform, तो इसमें सब्सक्रिप्शन और बिना सब्सक्रिप्शन वाले स्टूडेंट्स हैं. So it will be great if you can provide your details, like your you can say the ID or anything, जो भी आपका नेम है, रजिस्टर्ड नेम. वो सब तो है, लेकिन डाउट के लिए तो होना चाहिए ना. एग्जैक्टली जब ये लाइव सीरीज आएगी, तो वही मैं आपको बता रही हूँ कि डाउट्स आप लिखने शुरू करो सब्जेक्ट बाय सब्जेक्ट, और जैसे ही लाइव सीरीज. ओ यू आर क्षितिज. ओके क्षितिज, I'll forward this information to the team and you'll get the notification for the same. तो फ्रस्ट्रेट होने की जरूरत नहीं है, टॉपिक्स को प्रिपेयर करो. ओके, खुद अपनी तरफ से ऐसे प्रिपेयर करो कि आपको सब कुछ समझ में आ गया, बट जब आप मॉक टेस्ट करोगे ना, उस टाइम पे आपको अपने वीक एरिया समझ में आएंगे. बाकी मैंने आपको बताया हुआ है, टेलीग्राम ग्रुप में पोस्ट करो. आई विल टेक योर डाउट्स इन द यूट्यूब सेशन और इन द मास्टर क्लास. जब तक लाइव सीरीज शुरू नहीं होती है, टिल देन आई कैन डू दिस. मतलब यही कर सकती हूँ अभी मैं आपके लिए कि आप अपने डाउट्स भेज दो. आई होप आई आई गेस मुझे आपका नाम याद है, कौन से बैच में थे आप. सो क्षितिज, या तो यू कैन जस्ट ड्रॉप योर क्वेरी एंड आई विल टेक दैट इन द मास्टर क्लासेस. जस्ट लेट मी नो इफ यू आर कंफर्टेबल इन द मास्टर क्लासेस और इन द यूट्यूब सेशंस. लाइव सीरीज डेफिनेटली स्टार्ट होगी. क्विक रिवीजन और डाउट सॉल्विंग के लिए आनी ही आनी है, उसमें कोई चॉइस ही नहीं है. वेरी गुड इवनिंग कंचन. आई होप आपको थोड़ी सी क्लैरिटी आई कि कैसे प्रोसीड करना है. सो प्लीज डोंट वेस्ट योर टाइम वेट करने में और फ्रस्ट्रेट होने में. ये टाइम फ्रस्ट्रेट होने का नहीं है. एंजॉय योर लाइफ एंड Just revise the concepts. Okay, fine. So we have talked about A is representing the number of subproblems. Number of subproblems. N by B is representing subproblems. N by B is representing the number of elements in each problem or the size of each problem. And here main assumption is we are assuming that all the subproblems are having the same size. इसके basis पे एक question आया है in year 2020 January ISRO में. Master's theorem is based on, तो वहां पे चार assumptions given थी and one of the option was it is assuming that all the sub problems are having the same size. So whatever I'm writing here, each and every point is important, so please do consider that. And f of n is some additional time जो problem है उसको divide कर रहे हैं, solutions find करके जो merge करके we are returning the solution of the original problem. So that additional time is known as f of n. So f of n is the cost work done outside the recursive call, which includes the cost of dividing the problem and cost of merging the solution. So this is the additional cost. अब मास्टर्स थ्योरम अप्लाई कब कर सकते हैं? ये तो हुआ कि रेफरेंस रिलेशन का मतलब क्या है, यहाँ पे डिफरेंट टर्म्स जो गिवन है उनका मतलब क्या है. नाउ नेक्स्ट comes out to be how and when we can apply this Master's theorem. This is applicable when A is strictly greater than 1. Okay, positive term honi chahiye. A is strictly greater than is greater than equal to 1. Single sub problem bhi ho sakte hai, for example in case of binary search, but B should be strictly greater than 1. Strictly greater than 1 क्यों बोल रहे हैं? Equal नहीं ले रहे हैं because if I'll be taking B is equal to 1, तो ये आपके पास प्रॉब्लम क्या बन जाएगी? टी एन प्लस एफ ऑफ एन. इज इट अ वैलिड रिकर्सिव कॉल? Forget about solving this recurrence relation. This will happen if b is equal to 1. This will happen if b is equal to 1. And this is not a valid call क्योंकि यहाँ पे function is making a call to itself and number of parameters are same. Even the parameter value is same. अगर parameter value same है तो it will go to the infinite loop. So that's why we are saying that b cannot be equal to 1 but a can be equal to 1. So a can be greater than equal to 1, b is greater than 1. These are the constants and f of n is asymptotically some positive function. Then we can apply Master's theorem. I'm going to discuss just the cases of the basic Master's theorem first. तो क्या करना है? Let's come to this slide later on. We'll form these three cases. The very first step is identify that what is A, what is B. Okay, according to this format, you can identify that what is A and B. For example, here I'm considering this recurrence relation. I'm considering this recurrence relation, that is T of n is equal to 3T n by 3 plus n. So in this case, we know that A is equal to 3. Just compare it with this format. B is equal to 3 and n is nothing but this is f of n, this is n. Now check for the conditions. A should be greater than equal to 1, condition true. B should be strictly greater than 1, condition true. And f of n is equal to n. So on this recurrence relation, we can apply the Master's theorem. Now question arises is how to apply Master's theorem. Basic Master's theorem. Now, first of all, we need to find out the value for n raised to power log a b. अब n raised to power क्यों ले रहे हैं? Because when we are given with the function in terms of n, so we are talking about the polynomial function. So that's why here I'm finding log a with the base b. Okay. अगर आप f of n को strictly ले रहे हो कि it's n raised to power something, then directly you can do the comparison with log ab. So it's up to you whether you want to consider n raised to power or only log a with the base b. It won't make any difference. Okay. So find this value. अब इसको compare किससे करेंगे? Step 2 is compare f of n and n raised to power log a with the base b. इनको कंपेयर करेंगे. आफ्टर दैट कंपैरिजन करके क्या होगा, जब भी आप कोई दो वैल्यूज को कंसिडर करते हो, फॉर एग्जांपल आई वांट टू कंपेयर ए एंड बी, तो तीन पॉसिबिलिटीज आती है. ए कैन बी ग्रेटर, बी कैन बी ग्रेटर और बोथ कैन बी इक्वल. सिमिलरली हियर विल बी हैविंग थ्री केसेस. केस वन, आपके पास a है f of n, b is this one. So केस वन क्या होगा, f of n or n raised to power log a with the base b, this is greater than f of n. Other case could be f of n might be greater than n raised to power a की फॉर्मेट में लिखते हैं, n raised to power log a with the base b is less than f of n, and third case is both are equal. यही पॉसिबिलिटीज है. इन द एक्सटेंडेड मास्टर्स थ्योरम विल बी एक्सपैंडिंग ऑल दीज केसेस. ओके, एक्सटेंडेड मास्टर्स थ्योरम नाम से समझ में आ रहा है, जो बेसिक के केसेस हैं उनको थोड़ा सा और एक्सपैंड कर दिया. सो दिस इज n रेज्ड टू पावर log a with the base b is equal to f of n. Okay. Now we know that when we are returning the time complexity, we are returning the greater function. If this term is greater, then what will be the time complexity? It will be t of n is equal to theta of n raised to power log a. The formal way of writing this is different. हम एप्सिलॉन कंसिडर करके जो भी आपके पास ये टर्म आ रही है, जो दोनों में डिफरेंस आएगा, इट शुड बी सम कांस्टेंट टर्म. इट शुड नॉट बी लाइक वेरिएबल और एनी फंक्शन लाइक sine function, cos function, like that. So we will be doing the comparison on the basis of the difference should be in as a constant number. The only thing that you need to consider for your understanding for calculations, आपको उतना डेप्थ में लिखने की जरूरत नहीं है. सिंपली वैल्यूज फाइंड करो, कंपेयर करो, जो भी फंक्शन ग्रेटर है, रिटर्न दैट एज द आंसर, फिनिश. Here in this case f of n is greater, so what I'll be doing is I'll say that return f t of n is equal to theta of f of n. थीटा क्यों ले रहे हैं, क्योंकि दोनों को इक्वल प्रूफ करवाएंगे अभी by subtracting some value from the epsilon. So that's why usually we use the theta notation to represent the time complexity. In this case, when both are equal, so if I'll be writing t of n is equal to theta of f of n, अब दोनों इक्वल है, या तो f of n लिख लो या फिर theta of, or you can write this as theta of, or you can write this as t of n is equal to theta of n raised to power log a with the base b. If I'll be writing this term or this term, then we won't be able to distinguish that whether we are getting the equal case or whether we are getting one function greater than the other. So in order to break the tie, here we take log n. So you can take this with any of them because anyhow both are equal. So this is case 3. Make sense? Yes. So here are the cases. This is the more formal way of writing the basic cases of the Master's theorem. T of n is equal to a t n by b plus f of n. This is applicable if a is greater than or equal to 1 or b is strictly greater than 1 and function is asymptotically a positive function. If this is the scenario, then we have 3 cases. So in the first one, what we are doing is we are finding n raised to power log a with the base b. और दोनों को यहाँ पे हमने क्या बोले, दिस इज बिग O. बिग O मीन्स लेस देन इक्वल टू, सो n रेज टू पावर log a इज ग्रेटर देन फंक्शन f of n. और इसमें से जब आपने एप्सिलॉन सबट्रैक्ट किया, वेयर एप्सिलॉन इज सम कांस्टेंट वैल्यू, देन बोथ आर बिकमिंग इक्वल, राइट? सो फॉर एग्जांपल f of n is given as f of n is n and we are getting n raised to power log a b, this comes out to be n square. This is for our assumption. So what we can do is, अगर मैं इसमें से -1 कर दूं, then it will become equal to f of n. So in this case, epsilon is 1. Okay, so this is a constant function, so definitely we can apply the Master's theorem. Anyhow, if this function is greater, इसमें से subtract करें, so this function is greater, so answer will be n raised to power log a. If both are equal, अगर दोनों equal है, f of n is equal to theta of n raised to power log a, that means both are equal, then the time complexity will be returned as n raised to power log a into log n, or also you can write this as t of n is equal to theta of f of n into log n. Anyhow, both are equal. Third case, f of n is equal to omega of n raised to power log a, that means f of n is greater. तो दोनों को इक्वल करने के लिए क्या करना पड़ेगा? We need to add something to the power of n. Okay, after adding this epsilon, some constant value, both the functions are becoming equal. So we can say that anyhow here this function f of n was greater, so we are returning the time complexity in terms of f of n. This is more formal way of writing the things. The best way to remember or to handle the questions is simply आप n raised to power log a की value find करो, compare, and जो भी term greater है return it. If both are equal, then in order to break the tie, use log n. Make sense? Basic Master's theorem clear? Let's discuss one example from each case, and then we'll be talking about extended Master's theorem that is actually more useful. Anyone having any doubt in these cases? In cases में किसी को कोई doubt? फटाफट से confirmation दे दो, because I'll be giving you a reconciliation and you have to return the time complexities. तो कल हमने कुछ reconciliation solve किए थे, so I'll be taking those reconciliation ताकि आप comparison कर पाओ कि substitution method से, and you can use any method, anyhow you'll be getting the same answer. No doubt. All right. Thank you, Gautam, for the confirmation. Fine. So, are you all ready? एक छोटा सा practice session कहते हैं. T of n is equal to 2tn by 2 plus constant. What should be the answer? What will be the time complexity for solving this recurrence relation? Practice on different cases of Master's theorem. I'm just taking the cases from the basic Master's theorem. If you see here theta of n, very good. If you see here a is equal to 2 and a should be greater than equal to 1, so this condition is satisfied. B is equal to 2, n by b होता है, b is also strictly greater than 1, so we can apply the Master's theorem. F of n is constant. This can be written as n raised to power 0. Okay, now we will find a और b determine कर लिए, log a की value find करनी है, so n raised to power log 2 and with the base 2. We know that if the base is same, then it comes out to be 1. So this term is becoming 1, so it comes out to be 1. अब क्या करना है, इस value को compare करना है with f of n. We are going to compare n log a with f of n. First question है, इसलिए मैं depth में steps लिख रही हूँ, आपको इतनी depth में नहीं लिखना है. So if you compare this, this is coming out to be n raised to power 1, this is n raised to power 0. Which function is greater? Obviously n raised to power is 1 is greater, so we will say that here the time complexity comes out to be theta of n. Make sense? This is the first case when n raised to power log a is greater. So here I have applied the case when n raised to power log a is greater than f of n. So this is referring to, this is the example for case 1. So these are the steps that you need to follow. Next one. Second question, t of n is equal to t of n by 2 plus constant. Quickly return the answers for both the cases. Then we'll be we'll be covering the concepts of extended master's theorem. Hurry up, guys. Come on. Okay, theta of log n is the answer for the first case. Very good. So how we are getting theta of log n? If you identify here, a is 1, b is 2, and function f of n is some constant. That is nothing but n raised to power 0. We'll find out n raised to power log a with the base b. That is nothing but n raised to power log 1 with the base 2. 1 is nothing but that's 2 raised to power 0. 2 raised to power 0. So this will come here. It is n raised to power 0. Now these both the values are same. So that means here we are getting a case when f of n is equal to n raised to power दोनों values same है तो हम time complexity क्या return करते हैं? It is f of n. In order to break the tie, we have to take log n. So that is what I am writing here. So t of n comes out to be, this is some constant. So it's simply only log n. अगर आप n raised to power 0 लिख भी लोगे, anyhow that value is 1 only. So it comes out to be log n. Next one. Theta of n into n, that is n square. Okay. So yes, the answer for the next one is n square. This is related to, this was a case 2, example related to case 2. Next one is example related to case 3. Here a is equal to 3, b is equal to 3. जब दोनों values same है, obviously it comes out to be n only, n square. So we'll find out n raised to power log a with the base b. We'll compare it with f of n. This comes out to be n. And if you see here, this value is less than f of n. F of n is n square. So obviously f of n is greater. So we'll be returning the time complexity as theta of n square. Make sense? So this is about case 3. Anyone having any doubt in any of the case of the basic master's theorem? क्योंकि extended मतलब हम इसी को expand करेंगे इसके cases को. We'll go into more details. So guys, quickly give me the confirmation if all the 3 cases of the basic master's theorem is clear. So this here we have taken the example when f of n is greater than n raised to power log e. Anyhow, I'll be sharing this PDF in the Telegram group. Telegram group is Shefali ma'am Testbook. And also you get the link for all the YouTube sessions plus PDF. जैसे session खत्म होते हैं उसके 5 to 10 minutes के अंदर अंदर मैं PDF share कर देती हूँ so that you can refer to this PDF after the session to revise the concepts. And while revising, if you come across any doubt or any problem, you can post that in the group. You can directly interact with me. Quiz, you can also participate in the quiz and the poll in the Telegram group. Link is given in the description box. Try to search it, join the group. नहीं मिलता है तो session के end पे I'll share my screen and I'll show you that where is that link available. Okay. Otherwise, you can also search for Shefali ma'am Testbook. You'll get the group. I guess no query is there. So there are some limitations with the master's theorem, basic master's theorem. First of all, T of n should not be monotone. That is, T of n is equal to sin n. ऐसे functions को हम solve नहीं कर सकते. We can only solve the recursive functions. And f of n is not a polynomial. तो basically master's theorem कब work करेगी जब आपके पास function polynomial है. if you look at this function, this is exponential function. So here we cannot apply Master's theorem. A is not a constant number. A should be a constant number because we are applying the log on the value of A. So A must be a constant number. A should be non-negative function. It can be equal to 1 but not smaller than 1. Okay. So next is extended Master's theorem. अगर हम simply Master's theorem की बात करते हैं, we are just comparing the function like a polynomial function. Even we are not considering the log term in f of n. So extended Master's theorem is going to cover some more cases. Basic is same. A n raised to power b. We have to find out the value of n raised to power log a. n raised to power log a with b की value find करें. ये सब ठीक है. n raised to power k के साथ हम compare कर रहे थे. So same thing will be doing here. The only thing is in the format of the f of n. Instead of taking f of n, basic में हम क्या कर रहे थे? We were assuming that f of n is something like n raised to power k. n की पावर में है. Whereas in extended Master's theorem, we are assuming that f of n is n raised to power k तो है ये, इसके साथ में आपने कुछ logarithmic term लिया. अब ये p की value positive भी हो सकती है, negative भी हो सकती है, it can be 0 as well. Okay, if the value of p is 0, तो ultimately f of n comes out to be theta of n raised to power k. तो सीधी सीधी आपके पास if p is equal to 0, तो directly आपके पास basic Master's theorem बन जाती है. But if value of p is given, it can be positive value, negative value, then we are going to have few more cases. तो आप यहाँ पे notice कर पा रहे होगे main cases 3 ही है. Main cases are 3 only. Okay, so what we were doing is we were making the comparison between n raised to power log a and f of n, or f of n किस format में given था in the basic Master's theorem? It was given as n raised to power k. तो basically comparison तो सिर्फ इन्हीं दो का हो रहा है ना, because base is same. Yes. So on the basis of that, we are writing the cases here. If log of a is greater than k, तो इसका मतलब ये हमारे पास basic Master's theorem का first case बनता है. Because इसमें सब cases क्यों नहीं बने? Because if this term is greater, answer will be n raised to power log a. We are not considering f of n. यहाँ पे changes सिर्फ और सिर्फ किस में आए हैं? f of n में. So we are not considering f of n in case 1. So that's why there are no sub cases under case 1. Make sense? So t of n is equal to theta of n raised to power log a. It's exactly same what we have covered in the basic Master's theorem. Sub cases किस में बनेंगे? Case 2 and case 3 में. Why case 2 and case 3? Because when f of n is greater, we are returning the time complexity in terms of f of n. If both are equal, then we are writing f of n into log n in order to break the tie. So that means here we need to create the separate cases. So case 2, when log a is equal to k, अगर दोनों values same है, तो हम क्या करते हैं? We are returning the time complexity. Basic में we were returning the time complexity as t of n is equal to theta of n raised to power log k into log n. Or you can say f of n into log n. Okay, let me write this as f of n into log n. अब यहाँ पे अगर f of n में आपके पास already logarithmic term is present, हो सकता है आपके पास logarithmic term present हो, right? So if p is greater than -1, then we need to apply, एक log n कर रहे हैं और already आपके पास logarithmic term आ रही है. Greater than 1 means अगर p is equal to 0 है, then log की power 1 है. If p is equal to 1, तो log n तो आएगा ही आएगा टाई को ब्रेक करने के लिए, और एक log n पहले ही अवेलेबल था, तो it becomes, what I am saying is n raised to power, for example n square log n was the f of n, और टाई को ब्रेक करने के लिए आपके पास log n आ रहा है. तो here what is happening, we are just increasing the power of log n by 1. Okay, so this is if p is greater than -1, then t of n is equal to theta of n raised to power k log n with the power p. ये तो आपके पास f of n है, इसमें हमने क्या कर दिया, we are adding +1 because in order to break the tie we need to take log n. Make sense? Second one, if p is equal to -1 यानी कि logarithmic term आपके पास denominator में आ रही है, so n raised to power k -1 means log p की value अगर -1 है, so here we'll be getting something like log n into log n. तो ये तो cancel हो जाएगा. How do we get to know that? In order to break the tie, we need to take the log n. Log n बताएगा कि यहाँ पे दोनों equal थे, but यहाँ पे तो log n cancel हो गया. So we cannot simply take here log n. Here we will be taking log of log n. So if p is equal to -1, then the time complexity is returned as in terms of f of n. The only thing is instead of taking log n, we'll be taking log of log n. Okay. Third case, if p is less than -1, अगर p smaller than -1 है, यानी कि डिनोमिनेटर में आपके पास n raised to power k log square n. So log square n, that too in denominator, is a very small term. It won't make much difference. So simply we can return the time complexity as n raised to power k. So these are the three cases under when both the functions are equal. Correct? Similarly, if we have to return the time complexity in terms of f of n is greater than n raised to power log a, तो हमें f of n की फॉर्म में time complexity return करनी है. So if p is greater than or equal to 0, if logarithmic term is in the numerator or it's greater than 0, then simply we are returning the function as it is. Okay, तो हम क्या कर रहे हैं? Simply we are returning, then we are saying that just return the function as it is. यही बेसिक मास्टर्स थ्योरम में भी केस था. Although we were not having a logarithmic term, but here we were returning if f of n is greater, then the time complexity is f of n. But if we are given with the value of p and logarithmic term is present in the denominator में कब जाएगा? जब power negative होगी. Negative means if p is less than 0, then we'll not be considering this logarithmic term. We'll be just representing the time complexity in terms of n raised to power k. Is this clear? So these are the cases of the extended master's theorem. Anyone having any doubt in these cases? In cases में किसी को कोई doubt? If no, then we'll be solving the questions. Okay, practice on solving recurrence relation. Are you ready for the practice questions? So first case that I'm taking here is t of n is equal to let's say n by 3 plus n square log n. What will be the answer? Find out the value of A. Starting steps वही है. B is 3. We can apply Master's theorem. F of n is given as n square log n. Right? If you compare here k is equal to 2 and p is equal to 1. Find out the value of n raised to power log a, or simply find out log a, क्योंकि हम k के साथ कंपेयर कर रहे हैं log a with the base b. So what is this? This comes out to be log 9 with the base 3, that is nothing but 2. If you compare it with the value k, तो n square यहाँ पे आना था, square ही यहाँ पे आ रहा है, so this is case 2. This is case 2 when log a is equal to k. जब equal वाला case है, that means we have to use log n in order to break the tie. यहाँ पे already log की power 1 given है, so one more term will be coming up. So t of n comes out to be, it's f of n into log n, so theta of n square log square n. Make sense? So what we have done is, if it's a case of equal, then we are simply adding log n to break the tie. Already एक log n है, so it becomes log square n. Make sense? Next one, I'm just modifying this function, is equal to 9t n by 3 plus n square by log n. It's n square by log n. तो case 2 है ये भी, this is also the case 2. I'm just making a change to this logarithmic term, rest everything is same. So this is also the belonging to case 2, but here p is equal to, here we are getting p is equal to -1, right? If I'll be writing this in the desired format, this will be written as n square log n with the power -1. So in this case, k is equal to 2 and p is equal to -1. So we have calculated the value for log AB, that is 2. ये match हो रहा है, so this is case 2. Case 2 में particularly, when it's matching, then we are taking log n to break the tie, but यहाँ पे already denominator में this is power 1. So instead of taking only n square, we'll be returning the time complexity as n square. ये तो आएगा ही आएगा. Tie को break करने के लिए log n आना था, but there is a smaller function because this is going in the denominator, so we'll be taking log of log n. Make sense? So I'm talking about this case. Correct? Next one, let's take the third case here. It's also related to case 2. Case 2 में 3 cases हैं, तीनों ले लेते. So third one, t of n is equal to 9t n by 3 plus n square upon log square n. Now what will be the time complexity? अब दो बार तो log लेंगे नहीं, log of log n, that is not possible because ultimately we will end up by getting a term which can be negligible. So that's why we won't be writing this. So in this case, simply we'll ignore this logarithmic term. Yes. So here the time complexity comes out to be, we have already calculated this, it's theta of n square. Make sense? So here are the cases for case 2, subcases of case 2. Anyone having any doubt in this one? इसमें किसी को कोई डाउट? इसके बाद जो क्वेश्चंस आएंगे वो आपकी प्रैक्टिस के लिए होंगे. So just let me know, is this clear how we are applying these cases of extended master's theorem? Otherwise, अगर आपके पास ऐसे कोई logarithmic functions आते हैं, then you have to use the substitution method, because in that case we won't be able to apply the recursive tree method. So quickly give me the confirmation if it's clear. आप लोगों की रेगुलरिटी पता नहीं क्यों नहीं है. Evening, Sunday evening 6 p.m. we are having a session, so that means there is no excuse for the office or for the college or anything like that. अब संडे को ही होगा मैम, घूमने जाना होता है ना. So it's up to you कि प्रायोरिटी किस चीज की है. फटाफट से कंफर्मेशन दो, otherwise I'll go with my pace. Okay, next case. T of n is equal to 4t n by 2 plus n square. I guess we'll be getting the same case here. So let me modify this to n cube log n. Follow the steps. In this case, A is 2, A is 4, B is 2, and K is 3, P is 1. So we'll find out log A with the base B, that comes out to be 2. Log 4 with the base 2, that comes out to be 2. If you compare this, or basically what we are doing is n raised to power log A, and with the f of n, if you compare this, here we have n square, here we have n cube, so obviously this term is greater. यहाँ पे कुछ और term भी है. So that means it is case 3. This is related to case 3 of the extended master's theorem. And here this term is making this function greater because this is in the numerator, this is a positive function. So we will be returning the function as it is. So t of n will be equal to theta of n cube log n. Yes? This is when P is greater than equal to 0. And next one is, this is part A. Second example related to the same, B. T of n is equal to 4t n by 2 plus n cube by log n. Since here the logarithmic term is in the denominator, or we can say that p is equal to -1, अगर less than 0 है, then what is the case? यहाँ पे n cube numerator में, this is a greater function, but this term is making the smaller, it is reducing the value of the f of n, so simply we can ignore it while returning the time complexity, so it comes out to be only n cube. This is case B of case 3. Okay, so here are the two cases. First case mein I have taken the value of p greater than 0, and in the second case I have taken the value of p less than 0. So in our case it was -1. In this case it was greater than 0. I hope this is also clear. Next one, we are given that t of n is equal to 8t n by 2 plus n square log square n. This is the given function. What will be the answer? What should be the answer here? This is the last case that we are considering. After that, I'll be moving to the recursive tree method. So this is the last chance for you guys to ask the questions from Master's Theorem or from Extended Master's Theorem. लाइव सेशन में लास्ट चांस है. इसके अलावा आप चैट सेक्शन में लिख सकते हो, टेलीग्राम ग्रुप में लिख सकते हो. दैट इज ऑलवेज देयर. So what will be the time complexity? Quickly try to return the answer. I guess in this question, you need not to consider much cases. Theta of n cube, very good. So here we have A is equal to 8, B is equal to 2. this is K and this is P. K is equal to 2. We are going to find log A with the base B. So it comes out to be 3. 3. K is 2. अगर आप n raised to power वाली terms को compare करोगे, if you are following like by considering n raised to power a, तो obviously बात है इसका comparison हम किसके साथ करेंगे, n raised to power k. So if you observe here we are getting n cube and here we are getting n square. So this term is greater. इसके साथ कुछ और given है, that's fine, but that is a logarithmic term. So undoubtedly this function is greater. So we'll be returning the time complexity as theta of n raised to power log a with the base b. So in this case it is coming out to be cube. यहाँ पे आपको log की value consider करने की जरूरत नहीं है because it is independent of f of n. Is this clear? Can you expand the extended master's theorem? Mostly क्या होता है कि students get confused with the cases of the extended master's theorem. इतने सारे cases आगे basic तक तो ठीक है. They don't follow the concepts of the extended master's theorem. तो कुछ भी नहीं है, हमने basic master's theorem के ही cases को expand किए. Is this clear? Are you all comfortable with the cases of extended master's theorem? जितनी complex लगती है उतनी complex है नहीं. Provided you are not cramming the rules or the cases of the extended master's theorem, आप रट्टे नहीं मारो इन चीजों को, तो automatically आपसे easily हो जाएगा ये सब. Okay? So this is all about the basic master's theorem and extended master's theorem. Now I'm going to discuss the concept of recursive tree method. Third method to solve the recurrence relation, that is recursive tree method. So any recurrence relation, there are some recurrence relation which we can easily solve with the substitution method, master's theorem, and recursive tree method. For example, I'm taking t of n is equal to 3tn by 3 plus n. Okay, can we apply master's theorem over it? क्या हम master's theorem apply कर सकते हैं? If you observe here, a is 3, b is 3, और यहाँ पे तो logarithmic term ही नहीं आ रही, तो this is a case of basic master's theorem. So when I'll be finding out log ab, this comes out to be 1 only. And यहाँ पे भी n की power क्या है? So that is also 1. So we get to know that time complexity will be theta of n log n. This is n log n क्योंकि n raised to power log ab की जो value है, that is also n. So it's equal to the given function, which is equal to the given function f of n. So simply we can say that this is the equality वाला case. तो यहाँ पे हम break करने के लिए हमने log n ले लिया. So I have returned the answers with the answer with the master's theorem. In fact, I haven't used extended master's theorem. It's just the basic master's theorem. Other way of solving this is using the substitution method. We have covered the substitution method in yesterday's session. So we can use substitution method as well. If I'll be using substitution method here, this is method 1, using master's theorem. Method 2, using substitution method. So it comes out to be t of n is equal to 3t n by 3 plus n. Case 1. Here you'll be substituting the value 3t n by 3 square plus n hai, to here we'll get n by 3 plus n. So when you'll open these brackets, it comes out to be 3 square t n by 3 square plus here it comes out to be 3 into n by 3, it will be n only, so it comes out to be 2n. Second case. Like this, you'll come up with the series and we will get the series at the end. So using substitution method also we can solve it. Third one is using the recursive tree method. Method 3. Recursive tree method. I'll let you know that why we are covering recursive tree method. If a recurrence relation can be solved with master's theorem, तो easiest approach है कि a b की value find करो, log a with the b find करो, do the comparison and return the answer. So why we are going for the recursive tree method? That is because sometimes the problem is not divided into equal parts. एक assumption हमने master's theorem में apply की है. The sub problems are of same size. That means the number of elements in each sub problem are same. But ऐसा कोई जरूरी तो है नहीं कि हमेशा सेम आएंगे. So अगर सेम नहीं है तो master's theorem won't work. In fact, if you'll try to use the substitution method, तो आपके पास जो series बनेगी, that will be very complex. आप series बना ही नहीं पाओगे. So in that case, we'll follow the recursive tree method. That means if the problem is not divided into the equal parts, then we'll follow recursive tree method. If divided into the equal parts and b is greater than 1, condition satisfy हो रही है, then we'll go for master's theorem. अगर condition satisfy नहीं हो रही है, but the problem is divided into equal parts, then we will be using substitution method. So by looking at the recurrence relation, you'll be deciding that which method you want to use for solving a recurrence relation. Let us apply the recursive tree method on this one as well. यहाँ पे तीनों methods work कर रहे हैं. So in the original problem, n elements are there. We know that how to read this recurrence relation. In the original problem, n elements are there, and these elements are divided into number of parts are 3. This is getting divided into 3 parts, 1, 2, 3, and in each part the number of elements are n by 3. In each part the number of elements are n by 3. I hope that this is not going behind my image. Ab jayega, but let me switch off the video for few seconds. Okay. Now again, we will be dividing this into 3 parts. कब तक divide करेंगे? Until you get the termination condition. Tree में termination condition क्या होती है? When we reach to the leaf node. So here again divided into 3 parts. So it is saying that 1/3 of the original elements. So here we have n by 3. 1/3 of n by 3 is n by 3 square. This is also n by 3 square. N by 3 square. 3 square, n by 3 square. So I have divided this problem. Further, at the next level also, I'll be dividing this into 3 parts. 1, 2, 3, 1, 2, 3, 1, 2, 3. So every time we'll be dividing this problem into 3 equal parts because that's what is given in the recurrence relation. कब तक divide करेंगे? Until we reaches to the termination condition. So here we want 1. 1 means we want the leaf node. ये 1 कब आएगा? Let's assume that there are k levels, so it comes out to be n raised to power n divided by 3 raised to power k is equal to 1. तो ये कब आएगा? When k is equal to log n. Moreover, we know that if a tree is balanced and we are given with n elements, then number of levels in this tree, number of levels will be log n with the base 3. अब हमें लेवल्स पता चल गए, हर एक लेवल पे क्या कॉस्ट आएगी. वी विल बी फाइंडिंग दैट इफ n एलिमेंट्स आर गिवन, हियर इज द रेफरेंस रिलेशन. अगर n एलिमेंट्स गिवन है, देन द एडिशनल कॉस्ट इज n. So if n elements are there, then its cost is n. If n by 3 elements are there, its cost will be n by 3. N by 3 plus n by 3 plus n by 3, it comes out to be n. n by 3 square, n by 3 square plus n by 3 square कितने times add करें? 9 terms are there. So 9 into n by 3 square, that is also coming out to be n. So at each level, the cost of solving the sub problem is n only. तो ये कितनी बार आएगा? Log n times. So total cost to solve a problem with n elements is, at the first level it is taking n, at the second level it is taking n, at the third level it is taking n. So this way, at all the levels, it's taking n. This will be added for log n times. n plus n plus n अगर 3 times करते it will be 3 n. If I'll be adding n plus n for 10 times it will be 10n. और यहाँ पे हम कितने times add कर रहे हैं log n times, so it comes out to be log n log n. So this is what we were getting with Master's theorem. This is what we'll be getting with substitution method, and same answer we are getting with recursive tree method. But कुछ recurrence relations है जहां पे तीनों method work करेंगे. Now let me tell you that where we'll be preferring this recursive tree method. So if a problem is having same number of elements in subproblem, that is what that means. Size of subproblem is same. Size of subproblem, problems, प्रॉब्लम एक भी हो सकते हैं और मल्टीपल भी हो सकते हैं. साइज ऑफ सब प्रॉब्लम और सब प्रॉब्लम्स इज सेम, then we can use two methods. One is the substitution method and other one is extended or other method is simply the Master's theorem. It's a Master's theorem. तो आप दोनों methods use कर सकते हो. But Master's theorem में further constraint is there. We can apply Master's theorem only if the recurrence relation is given as a Tn by b plus f of n. We can apply this only if a is greater than or equal to 1 and b should be strictly greater than 1. Denominator में कुछ होना चाहिए. For example, if I'm getting the recurrence relation like t of n is equal to t of n minus 1 plus n. यहाँ पे आपके पास एक ही पार्ट है सब प्रॉब्लम का, तो डेफिनेटली वी कैन गो फॉर सब्स्टिट्यूशन मेथड बट नॉट मास्टर्स थ्योरम बिकॉज हियर वैल्यू ऑफ ए सेटिस्फाई कर रहे हैं कंडीशन को बट बी की वैल्यू सेटिस्फाई नहीं हो रही. Okay, so on this recurrence relation I can use the substitution method but I cannot use the Master's theorem. So basically these two methods are used when we have the concept of uniform distribution. Make sense? Uniform distribution. Now, if it's non-uniform distribution, then we cannot apply substitution method or Master's theorem. अगर आपके पास non-uniform distribution है, that means the sub-problems are containing different set of elements, then we cannot apply substitution method or Master's theorem. Non-distribution means here in this case, we will be going for recursive tree method. Is this clear to everyone that under what case we'll be using which method? Okay, so this is how you can decide which method you want to follow. Anyhow, अगर uniform distribution है तो आप recursive tree method भी use कर सकते हो. Recursive tree method is also possible. But the special case for the recursive tree method is if we have non-uniform distribution of the elements, then in that case, surely we'll be using only recursive tree method. Make sense? Let us consider one example for the same. Let's say t of n is equal to t of n by 3 plus t of 2n by 3 plus n. So if you see here in the original problem we are given with n elements. आपके पास n elements है और problem को हमने दो parts में divide किए. Problem is divided into two parts. First part is containing 1/3 of the elements, 1/3, and second part is containing 2/3 of the elements, 2 by 3 n. So it's not containing the same number of elements in the sub problems. So here we cannot use substitution method or master's theorem. So let's expand this tree. Here we'll be getting 1/3 of, first part is containing 1/3 of the elements. So 1/3 of n by 3 is n by 3 square. 2/3 of n by 3. So it comes out to be 2n by 3 square. 1/3 of the elements. So it's also divided into two parts. 1/3 of this 1 by 3 into 2 by 3 into n. This comes out to be 2n by 3 square. 2 by 3 into 2 by 3 into n. So it comes out to be 4 by 3 square into n. Similarly, we'll expand it further. Again, in the first part, 1/3 of the elements are there. So it will be n by 3 square. 2/3 of the elements, 2n by 3 square. 3 cube, 1/3. 3 cube. Here it comes out to be 1/3. So it will be 2n by 3 cube. 2/3. So it will be 4n by 3 cube. 1/3. 2n by 3 cube. 2/3. 4n by 3 cube. 1/3. 4n by 3 cube. 2/3. So it will be 8n by 3 cube. This way we can expand it further, but we need not to cover one by one. जैसे substitution method में हम 2-3 steps के बाद pattern observe करके we are getting the series, same thing will be doing here. So there will be log n levels in this tree. Okay, I'll talk about the base. Log n levels will be there. Base अभी मैं mention नहीं कर रही हूँ. So log n levels are there. Now we'll identify that at each level how much time it is taking. For n elements, it's taking n time. So this is taking n. For n by 3 elements, it will be taking n by 3. For 2n by 3 elements, it will be taking 2n by 3. So it will be n by 3 plus 2n by 3. Since the base is same, so it comes out to be n only. 3n by 3. So that is n only. At the next level, this comes out to be n by 3 square plus n by 3 square plus 2n by 3 square. So आपको ये सारी टर्म्स बार बार लिखने की जरूरत नहीं है. 4n by 3 square. 3 square is 9. न्यूमरेटर में देखो it's 1 plus 2 3 plus 2 5 and 9. 9n by 9 is n only. Here it is 3 cube, that is 27. In the denominator we have 27. 1 3 5 9. 9 and 6 is 15. 15 and 19 plus 8 is 27. It comes out to be 27n. So at each level we are getting the time required is n. तो सारे levels का sum जब लेंगे it will be n plus n plus n. How many times? Log n times. यहाँ पे मैंने एक part छोड़ा हुआ है. I'm not writing the base. We have to talk about the base as well. So this comes out to be theta of n log n. By any chance, previous question में भी हमारे पास n log n आया है, इसमें भी n log n आया है, but don't cram it कि हमेशा n log n आएगा. Majority questions में n log n आता है, but the question which was asked in 2022 वहाँ पे n log n नहीं था. So it's always good to construct a tree, check that how much cost it's taking at each level and finally take the sum of that. Now let's talk about the last point, that is what will be the base in this case. Okay, हमने levels find कर लिए, cost find कर लिए, what will be the case? In one part we are saying that it's dividing the problem by n by 3 और दूसरे में क्या कर रहा है? It is taking 2n by 3. I can write this 2n by 3 as n by 3 by 2, right? 3 by 2 is nothing but 1.5. So here I'm dividing the problem by 3 and here I'm dividing the problem size by 1.5. किसमें levels ज़्यादा बनेंगे? Which case will be containing more number of levels? Let us assume that the value of n is 10 or take any value. किस केस में केसेस ज्यादा बनेंगे? Let us assume that n is equal to 27. Okay, so n by 3, first of all we have divided this first level, 27 elements are there, divided by 3. At the next, 27 divided by 3 is 9. At the next level, 9 divided by 3 is 3. Third level, 1. We have reached to the termination condition. Moreover, we know that किसी भी number को आप greater value से divide करते हो तो it will reach to 1 in less number of steps. Here we are dividing this by 1.5. So 27, n is equal to 27 first level. 27 divided by 1.5. So it comes around 18. Yeah. Then next one is again divided by 1.5. It comes out to be somewhere around 6 divided by yeah, are we getting the right values? 27, 3, 9, 18. Yeah. So third step. Now 2 by 3 into 6, that comes out to be 4. Next, fourth level is created. 2 by 3 into 4, approximately this comes out to be 2, approximately 2. And here n will be one more level is created, approximately 1. So at least 6 levels will be there. यहाँ पे आपके पास points में value आ रही थी. But anyhow, in this case, we were getting 3 levels. Here we are getting 6 levels. Logically भी अगर हम सोचते हैं किसी भी number को अगर smaller number से divide करेंगे, it will be returning the greater value. So that means when we are talking about the time complexity, we have to consider the maximum time. तो हम number of levels किसके साथ consider करेंगे? With the base 3 by 2. With the base 3 by 2. So this is all about recursive tree method. I hope that this is clear to everyone that under which scenario we'll be using recursive tree method. Okay. Guys, is this clear? So this is all from my side. I'll be sharing this PDF in another 5 minutes in this Telegram group, that is Shefali ma'am Testbook. So you can join this Telegram group to get the daily PDF of all the YouTube sessions. You can post your queries, doubts in this session, in this channel. You can directly interact with me. You can also participate in the quiz and the polls. In the next session, we are going to start with divide and conquer and its applications. So divide and conquer is nothing but this is one of the algorithm designing technique. In our syllabus, 3 algorithm designing techniques are there: divide and conquer, greedy technique, and dynamic programming. हर algorithm designing technique के अंदर approximately we have 5 to 6 applications. So in total, we'll be covering 18 to 20 applications from these 3 algorithm designing techniques. So if you are comfortable with analyzing the algorithm, with the asymptotic notations, comparison of functions, solving the recurrence relations, that means 50% algorithms आपको समझ में आ गया, because mainly things are based on finding the complexities and the recurrence relations. So we'll talk about how this divide and conquer approach works, and we'll also talk about its applications. Anyone having any doubt? Okay, I promised you to share my screen so that you get to know that from where you can access the link for the channel. Okay, so I hope that my screen is visible. Yes, so currently this session is going on. तो जैसे ही बेटा आप इसके description में जाओगे, here you can see first link is for joining the master class. In the master class we are solving the previous year questions. आपने देखा होगा मैंने आज और कल वाले session में concepts discuss किए हैं, master theorem, substitution method और recursive tree के, but I have not discussed any previous year question. Okay, examples लिए हैं, practice questions लिए, to get more clarity over the concept, but we have not solved any previous year questions from any paper. So in the master classes, I'm covering the previous year questions. Second link is for, this is specifically for the students, those who are preparing for NIC Scientist B. Third link is for joining GATE Super Coaching Telegram link. So here is the link. You can follow this link to join the Telegram group. Next one is you can join the super coaching if you want to cover the 100% syllabus in detail. But I'm telling you, जो detail में concepts discuss होंगे, those will be in the recorded format. And you can see here multiple courses are available for from recordings from multiple institutes. So Gate Forum complete courses there, Digimento complete courses there, Nimbus Learning complete courses there, and the complete course by Shefali. That means me and my team. So you can follow the sessions of any faculty. In fact, अगर आपको कुछ sessions like Testbook वाले देखने हैं, Nimbus Learning के देखने हैं, you can also do that. If you want to follow any session multiple times, you can also do that. Okay, so this is there in the super coaching. You can have a look over the profile of the super teachers, demo classes, live series. Live series abhi start nahi hui hai for GATE CS because we want you guys to cover at least two subjects so that we can start with the discussion over those subjects. Okay, live sessions mein we will be having the quick revision sessions, doubt solving sessions, and the practice sessions. Okay, detailed concepts are, I'm repeating this point again, detailed concepts are in the recorded formats. You can join the mock test. इसके लिए आपको अलग से टेस्ट बुक पास प्रो लेने की जरूरत नहीं है. You will be provided with the study notes as well. Study notes, detailed notes भी होंगे और formula notes भी होंगे in the PDF format. You can download it. You can refer to these notes. So engineering mathematics, general aptitude, formula notes, 9 plus PDF means approximately 10 PDFs are there. One PDF for each subject. Whereas in computer engineering, you can see here we have different PDF notes for each and every chapter from each subject. For example, programming and data structures may approximately we have 5 units. So 5 PDF notes are there. जो ये detailed notes है, इनमें concepts are explained in detail along with the examples. Whereas in formula notes, only the important formulas and notes for that topic are there. ओके तो फॉर्मूला नोट्स बेसिकली हम प्रिपरेशन के टाइम पे रेफर नहीं करते. फॉर्मूला नोट्स आर बेसिकली रेफर्ड व्हेन वी वांट टू रिवाइज द थिंग्स. ओके, रिवीजन के टाइम पे विल बी यूजिंग फॉर्मूला नोट्स और एग्जाम जब आ रहा होता है उस टाइम पे इट्स वेरी वेरी बेनिफिशियल. जो यहाँ पे आपको ये प्राइजेस दिख रहे हैं फॉर द कोर्सेज 1 year, 2 year, 3 year, these prices are the discounted prices. Discount आपको कब मिलेगा? When you'll be using the coupon code. It's here, Shefali S, SHEFALIS. So when you go to the courses, you pick your plan, and after that, just for example, I have picked this plan, then you have to go to the apply coupon. So here you have to apply the coupon and you will get the discounted price. Otherwise, without coupon code, you'll be paying the full fee. Okay. So this is about super coaching and various plans. 1 year plan, 4th year students के लिए recommended है. 2 year plan is for second year or third year or fourth year तो नहीं, second और third year. 2 year plan में आपकी complete preparation हो जाती है. सेकेंड ईयर और थर्ड ईयर के जो आपके कोर टेक्निकल सब्जेक्ट्स है वो भी कवर हो जाएंगे, तो सेमेस्टर एग्जाम्स में भी बेनिफिट मिलेगा, कंपनीज में भी बेनिफिट मिलेगा, गेट में तो मिलना ही मिलना है बिकॉज गेट की प्रिपरेशन कर रहे हैं. अपार्ट फ्रॉम दैट, अगर आपने इसरो के सेशंस अटेंड किए होंगे, आज भी होगा एट 9 PM. सो व्हेन विल बी अप्लाइंग दीज कॉन्सेप्ट्स, तो आपको समझ में आएगा कि गेट की प्रिपरेशन आपकी इसरो के एग्जाम इसरो की प्रिपरेशन करते हुए हो रही है, और इसरो के सेशन में जो हम क्वेश्चंस डिस्कस कर रहे हैं उससे आपको एक अच्छा खासा सेट ऑफ क्वेश्चंस मिल जाता है फॉर गेट एग्जाम. तो syllabus is almost same, so definitely the aspirants of gate can join the sessions for the isro वाले gate वाले sessions join कर सकते हैं. Okay, so open platform है, कुछ पे नहीं करना है. So I'll recommend you guys to join the live sessions ताकि जो भी आपकी queries है वो साथ साथ में handle हो जाए. Okay. So yeah, we'll end our discussion here. If you guys have any doubt, you can ask. Let me quickly share the schedule that we are following. So if you have any queries, you can write that in the chat section. Otherwise, schedule that we are following: Monday to Friday, I'm taking 2 sessions for GATE, one on the YouTube and other one on the Testbook platform. Master classes are free. हर सेशन में मैं बताती हूँ, बट कुछ ना कुछ नए यूजर्स होते हैं, so I need to repeat these points. So YouTube session timing is 4 p.m. and master class is at 8 p.m. मास्टर क्लास की जो ड्यूरेशन है दैट इज जस्ट हाफ एन आवर. तो इसमें हम लोग क्वेश्चंस डिस्कस करते हैं, पीवाईक्यू सॉल्व करते हैं, एंड इन यूट्यूब सेशन वी आर कवरिंग द कॉन्सेप्ट्स. Here we are covering the concepts and here we are solving the previous year questions. And Saturday and Sunday I'm taking 2 sessions. Both are on the YouTube. First session is at 6 p.m. 6 p.m. to 7 p.m. Sometimes it goes to 7:15 or so, depends on the length of the topic. 7 p.m. and other one is at 9 p.m. दोनों गेट के लिए, बिल्कुल दोनों गेट के लिए नहीं है. ओके, तो सेकंड सेशन इज फॉर इसरो का नोटिफिकेशन आ चुका है. सो दिस इज फॉर गेट and this is for ISRO. Those who have not filled out the ISRO form, guys, application deadline is 14th of June. So it's already 4th. So quickly fill out the form 14th June. You can check for the detailed notification 2023. Maximum age limit is 28 years. So ISRO will be conducting its exam. Last time हुआ था ये January 2020 में. उसके बाद approximately 3 years के बाद एग्जाम हो रहा है. So obviously offline ही होता है ISRO का एग्जाम. For computer science, 47 vacancies are there, so you can take the advantage of this. तो अच्छी खासी vacancies भी हैं. DRDO का फॉर्म भी निकल चुका है, but it's recruiting on the basis of the GATE score. It's considering the GATE score. Okay, so cannot do much. So for that you need to write the GATE exam with full preparation and you need to score well. जिन लोगों ने अभी 2023 में GATE का एग्जाम दिया था but due to any reason they were not able to score well, then this is a good opportunity for you guys because already you have prepared for the GATE exam. So this is the time when you can completely focus on solving the questions. Again, cover all the previous year questions of the GATE. Along with that, solve the previous year papers of ISRO. Okay. So yeah, this is all about this session. Now I'll be meeting you guys at 9 p.m. in which we will be covering the previous year questions from ISRO. In today's session, I'll be taking the PYQs. Today, we will be covering PYQs on DBMS and digital. कौन से ईयर के 2020. तो मैं ईयर बाय ईयर सब्जेक्ट बाय सब्जेक्ट 2 सब्जेक्ट्स के क्वेश्चंस लेते हैं एक सेशन में एंड वी आर डिस्कसिंग देम इन डिटेल ताकि आपकी क्विक रिवीजन भी हो जाए और पीवाईक्यूज भी कवर हो जाए. ओके, सो थैंक यू सो मच गाइस. आई विल सी यू एट 9 p.m. टिल देन टेक केयर, बाय बाय, गॉड ब्लेस यू ऑल.